Hello friends, today we are going to discuss that how to solve the numerical from the topic fuels and combustion, which is one of the most important topic in engineering chemistry. So in this video we are going to discuss how to solve in a most easiest way, easiest way for this different kind of numerical. This numerical can come from the different segment of the chapter. See, the first one, which is related to the HCV and LCV. We all know what is HCV. HCV is the high calorific value, LCV is the low calorific value. So we can solve this kind of numerical with the help of Dulong formula that we are going to discuss. Then we are going to discuss the proximate analysis. We all know that proximate analysis we are carrying out to understand the quality of the coal. Like in the proximate analysis, we can calculate the percentage of moisture, percentage of volatile matter, percentage of fixed carbon. All these things we are going to discuss in this proximate analysis, how to do. Now in the third part, we are going to talk in the ultimate analysis. We will take the example of each and every category. And we'll solve it on the board, and I'll try to make such a easiest way so that everyone can understand easily. And that is ultimate analysis. In the ultimate analysis, we know that we would like to calculate the percentage of carbon, percentage of hydrogen, percentage of nitrogen, percentage of sulfur, percentage of oxygen. All these things we are going to show you how to find it out in most easiest way. Then the fourth part is the calculation of amount of air required for the combustion of unit mass of fuel in terms of weight. It means suppose I want to burn 1 kg of coal sample. So how much amount of oxygen or how much amount of air is needed, that we are going to calculate in this example of numerical. In the last part, that is calculation of amount of air. That is very, very important. At the end we are going to discuss, suppose I want to burn that 1 unit mass of fuel. Unit mass of fuel. So, and I would like to see how much volume of oxygen and how much volume of air is needed to for that purpose. So that we are going to discuss in the last part, that is calculation of amount of air. So now let us take one example of each and category. What we'll do, let me tell you the plan. The plan is for each and every category, I am going to take one numerical as an example and try to make you understand in most easiest way. So let me start with the first numerical, and I already told you that first numerical going to from the HCV and LCV or GCV or NCV. Look at the numerical. The same similar kind of numerical you can expect in the exam also. A sample of coal contains carbon 70%, oxygen 20%, hydrogen 6%, sulfur 2.5% and nitrogen is 1.5%. Calculate the gross and net calorific value of the coal. Straightforward numerical. Values are given. We know how to do it. So we'll start. We know from Dulong formula, that HCV or GCV is equals to 1 by 100 into 1 by 100 into 8080C plus 34,500 H minus O by 8 plus 2240S and then calorie per gram. So this is the formula. This is the formula that we know, and you can see 80C, 80C and 34,500 H minus O by 8 2240S calorie per gram. What you have to do, you have to simply put the value 1 by 100. So 8080 cc is 70, so we have to write 70. That is something interesting here. You no need to convert the percent into the fraction. You have to directly put the value 70%, so 70. Why? Because we have taken 1 by 100 common outside. So and then 34,500 H. What is the value of hydrogen here? 6. 6 minus oxygen is 20, so 20 by 8 plus 2240 S is 2.5. so I'm just putting the value, and the unit we have to mention either calorie per gram or kilocalorie per kg. That you need to be clarified. Now after calculation we will get the value. The value will come around 6919.50 calorie per gram. Okay, calorie per gram. Now this calculation I am not worried because students are allowed to use calculator. But only thing, what is, you have to write the formula first and then you have to put the value properly. Okay, and as I said, you need to cross check your answer always. Now we got the first answer we got, that is GCV. Now I have to calculate LCV or NCV. That's what they ask. That is the net calorific value we can see, and we know the formula again, and that is HCV minus 9H by 100 into 587, okay, and that is calorie per gram. Again I am maintaining the same unit, so you can see HCV value is given 6919.50 minus 9 into H value is already given 6 by 100 into 587, that is the enthalpy of condensation. We know very well the unit remains same, calorie per gram, and if you calculate it will come around 6602.52 calorie per gram. So this is my second answer and that is my first answer. So this is how, so simple to solve such numerical. Okay, now remember one thing is there is a cross check point, because this is, you are saying HCV high calorific value, LCV low calorific value. Obviously your HCV value always higher than the value of LCV. Okay, this is the way we should do it, this kind of numerical. Now I am going to for the second type of numerical. Okay. Okay, now we are going to discuss the second numerical, and that is purely based on the proximate analysis. Okay, so look at the numerical. As I said, that similar kind of wording you can expect in the exam, only the values might change. 2.5 gram of coal sample after heating at 110 degrees centigrade for 1 hour gives a residue of 2.41 gram. So from this line you are getting two information. The first one is, that is the weight of, okay, weight of coal sample is given, that is 2.5 gram, that is given. Okay, weight of coal sample, that is 2.5 gram. Okay, that is given. So this is our first. The second one is, there is a loss in weight. Okay, you can see initially I have taken 2.5 gram, that is the weight of the coal sample. Now there is a loss in weight. Now this loss in weight obviously due to the moisture. Okay, so can I write that loss in weight due to moisture is 2.5, okay, 2.5 minus 2.41 gram equals to 0.09 gram. So this is the loss in weight due to the moisture. So I can easily calculate the first one, that percentage moisture. Okay, percentage moisture, we know the formula, that loss in weight due to moisture divided by, okay, weight of coal sample into 100, because we are finding percentage. So loss in weight is how much? 0.09. 9, and you can see the weight of coal sample is given, that is 2.5 into 100, and if I'm not wrong, that will come 3.6%. okay, 3.6%. so that is my percentage of moisture. Now we go for the second line. The residue was further heated at 925 for 7 minutes. So this condition is purely for the volatile matter, we know that. Okay, so this condition, it means there is a loss in weight, and this loss in weight is due to the removal of volatile matter. So we can write that loss in weight due to volatile matter, in short we will write VM, is what? That is your 2.41 minus, okay, 2.41 minus 1.98, and that is 0.43 gram. Okay, 43 gram. So here the student need to be careful. Why I have subtracted from 2.41? Why not from the 2.5? You remember, first you have already removed the moisture. After removing the moisture, you are removing the volatile matter. So in case of volatile matter, always you have to subtract the weight left after the removal of moisture. Okay, so 2.41 minus 1. So now we know the formula, that percentage volatile matter, okay, percentage volatile matter is the loss in weight due to volatile matter divided by the weight of coal sample into 100, and that will come how much? Okay, so that will come like I can write from side by side 0.43. okay, and what is the weight of the coal sample? And that is 2.5 into 100, and it will come 17.2%. okay, 17.2%. so now we understood. So this is our first answer, that is volatile, that is the moisture content. This value is due to the volatile matter. Okay, now we can see that there is okay, to give a weight of 1.98 gram, we understood. The residue was ignited to give a constant weight of 0.246. This constant weight is related to the ash content, that is non-combustible part. That is the reason they are giving the fixed value. So I can write that percentage of ash content is equals to, okay, I can say fixed weight of residue divided by weight of coal sample into 100 is equals to, what will happen? That is 0.246 by 2.5. 2.5 is my initial weight of the coal, and this value will come around, if I'm not wrong, around 9.84%. 9.84. So that is your percentage of ash content or non-combustible part. Okay, so that is there. Now that is not my answer. What they have asked, they asked to determine the percentage of fixed carbon. So we know the formula, that percentage of fixed carbon is equals to 100 minus percentage moisture plus percentage volatile matter plus percentage of ash content. Okay, so this is in percent. So if I put the value, now we have the moisture is how much? 3.6, volatile matter is 17.2, and the ash content is 19.84. so you can get the answer is 69.36%. so that is my answer. This is my answer. Okay, this is my answer. So this is how we are going to calculate. This is how we have to do the calculation in order to find out the answer for the proximate analysis. Now we go for the one numerical example for the ultimate analysis. Now we are going to discuss the third numerical, and third numerical on the ultimate analysis. We already know what does it mean. We know the significance of the ultimate analysis. Now in this segment, in this numerical, we are going to discuss how to calculate the percentage nitrogen and sulfur. But remember, the percentage of carbon and percentage of hydrogen, that kind of numerical is also possible, but they are very easy. One student can easily do that. So I am particularly taken one example which is coming frequently in the exam, that 3.2 gram of coal sample was heated in gel dust flask. So it is the moment you know the gel dust flask we are talking about, means I am talking about the determination of percentage nitrogen, and that you can see that calculate the percentage of nitrogen. So 3.2 gram of coal sample was heated and ammonia evolved was absorbed in 40 ml of 0.5 normal H2SO4. So here you can see the volume of acid taken. So can I write? Let me start. That weight of coal sample for nitrogen determination. The nitrogen determination, okay, let me say this is X, okay, or let me write this is W, okay. W1 is equals to how much? 3.2 gram. 3.2 gram, that is given, okay, 3.2 gram, that is given. Now another information is given, like volume of acid taken equals to 40 ml of 0.5 normal. Normality is required in the equation. And now you can see, okay, the excess acid requires 16 ml. It means that volume of excess acid is equals to 16 ml. It means that volume of acid, okay, volume of acid taken, let's say this is X. Volume of excess acid, let's say this is Y. So volume of acid reacted, that is X minus Y, that is 40 minus 16 is equals to, you can say this is a 24 ml. Okay, 0.20. So this much amount of acid react with the ammonia, that we need to understand. So volume of acid taken X, that is 40 ml, is clearly mentioned here. Now how much acid is excess? That is 16 ml. So how much volume of acid reacted? And that is X minus Y, 40 minus 16, or you can say this is the volume of ammonia produced. Okay, so that is what. Now we know the formula, that percentage nitrogen is equals to X minus Y. Okay, I can write X minus Y because I have already mentioned what is X minus Y, that is volume of acid reacted, into normality into 1.4 divided by weight of the coal sample taken for the determination of nitrogen. Now if I put the value, let me put the value, that X minus Y is 24, normality is 0.5, okay, into 1.4 divided by, what is the W1? 3.2, and I think this will come 5.25%. So this is our first answer, 5.25%. So one thing you can see how the numericals are so easy. But one thing everyone need to remember, that you cannot put the value directly. First of all, you have to write the equation, then you have to put the value and do the calculation with the help of calculator. Okay, so this is something. And whenever you report your answer, remember you have to report your answer with the unit. Okay, with the unit. Now the second part. Now we are done with this first part is over here. Okay, now the second part, 2.5 gram of coal sample was analyzed for the sulfur. Okay, so can I write that weight of coal sample taken for sulfur analysis, W2 is equals to 2.5 gram. Okay, 2.5 gram. Now, how much coal sample on analysis gives 0.42 gram of barium sulfate? So can I write that weight of barium sulfate? Look at here, I am not writing anything different. What is given, the statement, the sentence is already given in the numerical. I am just writing the same. Weight of barium sulfate, X equals to how much? 0.42 gram. Okay, given. So now we can know the formula of sulfur. Percentage sulfur is 32 into X by 233 into 100 by W percent. So this is, here I write W2, okay, 100 by W2, 32X by 233 into 100 by W2. So now you have to just put the value. If I put the value 32 into X, what is the value of X? The value of X is 0.42. Okay, the value of X is 0.42 and divided by 233. 233 is the molecular mass of barium sulfate. Remember that, into 100 by W2. W2 is 2.5. So this will come 2.307%. So this is my second answer. And that exactly they have asked for percentage nitrogen and sulfur. We have calculated both. Okay, so this is how we can do in a very simple and easiest. You have to follow the sequence, given value, put the value, put the equation, write the equation, put the value, do the calculation, okay, and report the answer with the unit. So this is the numerical on ultimate analysis. Okay, now we go for the another part numerical, which is on that calculation of amount of air in terms of weight. So let us start the fourth example of numerical, and that is purely on the to calculate the amount of oxygen or the amount of air in terms of weight for the combustion of unit mass of fuel. Okay, so look at the numerical. A coal sample was found to contain the following constituent. Okay, carbon. So I have write 3 columns. Okay, same thing expected from while you doing the calculation in the exam. Okay, the similar way you can go ahead. Constituent carbon, percentage by weight is 81. Then we have oxygen. Oxygen is 7%. Then sulfur. Sulfur is 1%. Then hydrogen. Hydrogen is 6%. Then we have nitrogen. Okay, nitrogen is 1% and remaining is the ash content, and that is 4%. Okay, so let me read the numerical. Carbon 81%, oxygen 7%, sulfur 1%, hydrogen 6%, nitrogen 1%, and ash content is 4%. Calculate the amount of air required for the combustion of 1 kg of coal. That is the something new. That for combustion of the coal, we need oxygen. So first of all, we need to find out the oxygen, and then you know that oxygen by weight, okay, 23% exists in the air, because the source of oxygen is the air, and we all know that 23% oxygen by weight is present in the air. Okay, so we have a direct formula to do this such kind of numerical. Okay, so first of all, you have to do 3 columns. Constituent I have written, percentage by weight given in the numerical. So what is this? Weight of each per kg of fuel. So we have to just convert into fraction. So 81%, so this is 0.81, 7%, so 0.07. Here I am requesting all the students to be careful. 7% means 0.07, 70% means 0.7. 7 means 0.07, that we need to be careful. Sulfur is 0.01, hydrogen 0.06, nitrogen no contribution, we know very well, no contribution. Ash content, again no contribution, that we need to write in this column. Okay, so these are the value we have. So now we have the formula. The formula I am writing directly here, that amount of air required for 1 kg, okay, for 1 kg of fuel is equals to, okay, we know the formula, that is 100 by 23 2.67 C plus 8H plus S minus O, okay, and that is in kg. Okay, that is in kg. So you can see that amount of air required for 1 kg of fuel, 1 kg of coal sample, how much is needed. Now if in the numerical they have asked to calculate for 2 kg, for 5 kg, first of all you have to calculate for 1 kg. That is the reason I have purposefully wrote it, that whatever the 5, using the formula, whatever the value you are getting, that is for 1 kg of fuel. Suppose they ask for 5 kg, so you have to multiply the answer into 5. Okay, so this is what you have to remember. Now amount of air needed for one. Now we can see I have directly put the value 100 by 23 2.67 C. Okay, I have just missed it, C. Now see, how is the value of C here? It is 0.81, okay, plus 8 into hydrogen is how much? Hydrogen is 0.06 plus sulfur is how much? Sulfur is 0.01 minus oxygen is 0.07 kg. Okay, so this is how we have to put the value, and now we are going to calculate the answer with the help of calculator. So the answer, you have to, as I said, you have to use the calculator and you have to write the answer, and here we will get 11.229 kg. So this is my answer for this numerical. Okay, one thing I hope everyone noticed, that the numerical are so easy. Okay, all the numericals are so easy, straightforward. The values are given. Only thing you have to do it in a proper way by writing the formula, put the value, do the calculation. Now we go for the last example, okay, and that is the calculation, again the volume of oxygen and the volume of air for the gaseous fuel. So we are going to discuss the last example of the numerical segment, and that we are going to discuss that how to calculate the total volume of oxygen required for the combustion of unit mass of gaseous fuel. And I already said that the oxygen is coming from the air, and air contains 21% by volume of oxygen. Okay, everything is needed, so let's start one by one. So first of all, again you have make the column, okay, in the form of table. So first one is the constituent. We have, you can see a gas has the following composition by volume. So here we are talking in terms of volume. So remember, when there is a volume, your unit will be meter cube. If they are asking in terms of weight, then your unit will be kg. So that we need to understand. A gas has the following composition by volume: hydrogen 20%. So we have first constituent hydrogen 20%, so 0.20. CH4, methane 6%, so this is 0.06. Then carbon monoxide is 22%, so this is 0.22. Then carbon dioxide is 4%. Okay, I am not writing percent, so 4, and we know that this is does not contribute, because carbon dioxide is non-combustible. Carbon dioxide. Then oxygen is 4%, very interesting, so 0.04. And then nitrogen, even though it is very high, 44%, but nitrogen is also non-combustible, so does not contribute. Okay, does not contribute. So this is how we have to make the table, the first table. That's how we should make it. Okay, now we'll talk about that we have to calculate the volume of oxygen, and volume of oxygen can be calculated with the help of some chemical reactions, because we need to understand, we need to know that for one part of hydrogen how much oxygen is required, for one part of carbon monoxide or CH4 how much oxygen is required. So we have to write the chemical reactions of combustion for each and every constituent. So let me start from hydrogen. So we know that H2 plus half O2 give you H2O. So it means one volume of hydrogen require 0.5 volume of oxygen. You can see that half means 0.5. Okay, so now how to write it? So we can write that 1 meter cube of hydrogen required 0.5 meter cube of oxygen. Okay, point. Now how much hydrogen we have? 0.20 meter cube. So 0.20 meter cube of hydrogen require 0.5 into 0.20, then that will come 0.10 meter cube. So this is how we have to do for hydrogen. Okay, this is for hydrogen. Now can we go for methane? Again we know that CH4 plus 2O2 give you CO2 plus 2H2O. So here you can see one volume or 1 meter cube of methane require 2 meter cube of oxygen. So I can write 1 meter cube of methane required 2 meter cube of oxygen. So how much methane we have? 0.06. So 0.06 meter cube of methane require 2 into 0.06, it will come 0.12 meter cube of oxygen. So this is the first one, this is second one. Now we have to go for the carbon monoxide. So we know carbon monoxide plus half O2 give you carbon dioxide. So 1 meter cube of carbon monoxide require 0.5 meter cube of oxygen. So how much carbon monoxide we have? It is very high, 0.22. So 0.22 meter cube of carbon monoxide require 0.5 into 0.22. It will come 0.11 meter cube of oxygen. Okay, so carbon, what else? So hydrogen done, CH4 done, carbon monoxide is done. Okay, now oxygen obviously non-combustible, that you have to remember, but contribution is there. So I have just taken this value. Very soon I'll tell you. Now we can write since 0.04 meter cube of oxygen is present in fuel. That is something interesting. So what we are calculating, sir? We are calculating the total volume of oxygen. Now you can see in the fuel itself some amount of oxygen is present. It means that much oxygen we no need from the outside. So how to calculate? So total volume of oxygen required is equals to, we can take the summation of all the values. Okay, summation of all the values, like first one is 0.10, then 0.12 plus we have this one 0.11 minus 0.04, and that will come, if I'm not wrong, 0.29 meter cube. Okay, so this is the values are given, and this value will come 0.29 meter cube, total volume of oxygen required. Now this oxygen, this is the volume of oxygen required. Now this oxygen will come from the air. So can I write, because what they have asked, they asked the find the volume of air. Okay, find the volume of air required per meter cube of combustion. So volume of air. So let me write that volume of air is equals to 100 by 21 into 0.29 is equals to, so let me see, they have asked to calculate, okay, that is asked to calculate the volume of air. So this will come 1.38 meter cube. So this is my answer. So 1.38. So volume of air required is 1.38 meter cube. Remember, this much volume is required for 1 meter cube of fuel. Suppose in the numerical they ask calculate for the 5 meter cube of fuel, then you have to multiply this value by 5, or else if they ask to calculate for 2 meter cube of fuel, you have to multiply this value with the 2. Okay, so this is how we have to do the calculation. This kind of numerical easily expect in any form of experiment examination. Okay, and I hope we have discussed well, and that will help all the students to understand and to solve the numerical in most easiest way. Okay, so thank you very much. Namaskar.